So in this video, I'm going to talk about some of the fundamentals of geometry, and primarily it's going to be points, lines, and planes. And we'll talk about how to draw them, how to use the proper notation, and then we'll talk about some of the postulates that have to do with points, lines, and planes. Really, just some of the basic rules of geometry. So before we can really go any further, we have to talk about how to draw each and what each of these terms actually mean. So for point A. What a point is really just a location in space that is infinitely small. Now, when we draw a point, we kind of symbolize it by just using a dot, and we can label it with a capital letter. So that blue dot that I've drawn is not actually a point, but representing a point, because a point is infinitely small, and even that blue dot right there is made up of an infinite number of points. But a point is by definition just a location in space. So that point right there would be called point A. Okay. If I then wanted to draw line AB, which you can write as line AB like this, or you could write it using line notation, which would be AB with a line drawn over the top of it, arrows on both ends, because a line extends infinitely in opposite directions. Or you could even write it as line BA, because line AB and line BA are actually the exact same thing. So if I'm going to draw line AB, it's going to have to go through point A, and I'll make that a little bit darker there. Okay, there's point A, and it's going to have to go through point B. Okay, so that line is, by definition, the sum of all points between A and B and extending infinitely in both directions forever. A line is infinitely long and infinitely thin. A line has no thickness to it. Okay, but since line AB contains all the same points that line BA contains, we can say that line AB and line BA are exactly the same. Okay, when we talk about ray AB, well, a ray is a little bit different from a line. Ray AB, which can also be written as AB with an arrow pointing to the right over it, that's talking about all the points that begin at point A and extend infinitely forever through point B. Okay, but it's not the sum of all points in both directions, but just one point. Okay, so that would be ray AB. Now, ray AB is not necessarily the same thing as ray BA. In fact, ray AB is never the same thing as ray BA. Ray BA would still be written as BA with an arrow to the right over it. Ray BA is going to be the sum of points extending infinitely in the opposite direction, this way here. Okay. Now you may see in some textbooks, or we may have talked about in class already, the difference between rays pointing in opposite directions and opposite rays. So even though ray AB and ray BA extend forever in opposite directions, AB and BA are not opposite rays. Opposite rays have to have the same starting point. So if I put another point in here, we'll call this point C. Well, now I could say that ray CA, which looks like that, and ray CB, which looks like that, those would extend in opposite directions, and they have the same starting point. So ray CA and ray CB would be opposite rays. Next, we have segment AB. Well, segment AB is really just all of the points between point A and point B inclusive. So segment AB is going to be all of these points highlighted here. This is going to be segment AB in that area there. All right. And segment AB has all the same points as segment BA, so we can actually name those as the same point, the same segment rather. So we can write it as AB. Oops. Get rid of that. We can write it as AB with a segment over it, or we can write it as BA with a segment over it, and these are the same. So remember that line AB and line AB and line BA are the same. Segment AB and segment BA are the same, but ray AB and ray BA, those are different. Okay. If we talk about a plane is a two-dimensional surface extending infinitely in two dimensions. In other words, it's like a flat surface that extends forever in 2 dimensions. It has no thickness. So the way we represent a plane is usually by a parallelogram. So we'll draw something like this for our plane. And if we want to have plane AB, we're going to move these points here onto the actual plane. There we go. And so now line AB is on this plane, but because a plane is 2-dimensional, we actually need a third non-collinear point in order to name it. So like this line needs 2 points. You need 2 points to name a line. You actually need 3 non-collinear points to name a plane. So I'm going to take point C, and I'm going to put point C just over here somewhere so it's not on the same line. So now I could call this plane ABC. Some books or some problems may name lines and name planes a little bit differently. Sometimes you'll see a line just with a cursive letter, so that could be line L, and a plane might be named with an uppercase cursive letter, so this could be plane P. Okay, so you can call it plane ABC or plane P. You can call this line AB or line L. All right. Next, we're going to talk about some of the important postulates that come up with points, lines, and planes. And the first is that through any 2 points, there always exists a line. It doesn't matter what point you're talking about, there's always a line. So clearly I can see over here that F and D are collinear. There's a line between them. But if I took points like F and C, line FC is not drawn, but it does exist. It could be drawn because we could draw that line right there and it would work. Through any 2 points, doesn't matter where they are, there's always going to be a line that contains them. And just like since a line is 1-dimensional and takes 2 points to define it, a plane is 2-dimensional, so it takes 3 points to define it. So through any 3 points, there always exists at least one plane. All right, and if those points are non-collinear, all right, non-collinear meaning they're not on the same line, that means that there's only one plane. So if I took points like F, D, and A, those are non-collinear points. There's only one plane that goes through all of F, D, and A. All right. If I took 3 collinear points, like for example A, B, and C, well, now there's an infinite number of planes that would contain them. And you can see 2 of them are actually drawn here. The first one we have is this horizontal plane, plane P, and the other one we have is this vertical plane, the shaded plane here, which we can call plane FDE. Okay, and there would actually be an infinite number of more as we rotate those planes around that line. All horizontal planes are parallel, but not all vertical planes are. For example, if you think of the room you're sitting in right now, the floor and the ceiling are going to be horizontal planes, but the walls are going to be vertical planes. So if you look at any one of the corners, that's where two vertical planes intersect. All right, that's not going to be parallel. If 2 lines intersect, they intersect in a point. So for example, line DE and line AC intersect at point B. And if 2 planes intersect, then their intersection is going to be a line. Plane FDE and plane P, they're going to intersect at this line right here, line N or line AC. Just like if you look at the room you're in, if you look at the corner where those 2 walls, which are vertical planes, they intersect, that corner of the room forms a line. Okay. So let's try a little bit of practice here. If we look at this next one here, you can try and pause this as you go through. I'm just going to work on through it, but if you want to try these on your own first, it's not a bad idea. Name the intersection of plane P and plane FDE. Well, we just talked about that on the last slide. So those planes intersect in line N or line AC, or you could call it line CA, BA, AB. Any of those would work. Our lines AC and DE coplanar. All right, so these are going to be lines. So we'll put the little line symbol over them. And I want to know, are they coplanar? Well, here's AC and here's DE. And the answer is yes. Intersecting lines are always going to be coplanar. In fact, I can see that they both are contained by that shaded plane. Remember the shaded plane, even though it looks like it has edges, planes don't really have edges. They extend forever. Does line FG exist? Well, it must, because through any 2 points, there's always, always, always going to be a line. So even though I may not have the line in my diagram, that doesn't mean that it doesn't exist. It clearly can be drawn. So through any 2 points, there's always a line. The last one is to name a pair of opposite rays. Well, in this diagram, there are 2 pairs. Right now I see there's ray BA and ray BC. Right? They have the same starting point but go in opposite directions. There's also going to be ray BE and ray BD. Right? And those would also be opposite rays because they have the same starting point and go in opposite directions. All right. So I hope this video helped clarify some of that stuff. These really are kind of basic rules. Some of them are pretty intuitive. Some of them you probably already know, but they're really, important as far as what you need to understand in order to build in future lessons. So I hope this video helped, and I'll see you next time.